So in this question, I'll first explain the underlying concept that you have to use, and then applying it is actually easy. So let's say you have to go from point A to B. If you look at the condition here, you're either going one coordinate unit up or one to the right. So imagine going from point A to B. Your one option could be you go like this, again straight, and then up, up, and then this way, and that, and that. So that's one possibility. So you have lots of different paths you can take to go from A to B. But in all of these, if we say the direction, this is going east, and then that's going north, you're either taking a turn to the east or north. And when you get to this point B, you've taken, if you look at this, you have a total of 4. So you've taken 4 east steps and 3 north. Why? Because we have 3 lines going up. And in particular, this example, you have east, east, you take 2 steps, then north, north, then east, then north and east. So that's the sequence, but you'll see the total is 7. And that would be the case if you go this way, 3 north and then 4 east. That would look like this. So the link really is that the number of paths to go from A to B is really about rearranging these 7 letters, where 4 of them are E's and 3 of them are not N's, not 9. And the number of ways we can do that, where 4 are identical and 3 are identical, is 7 factorial over 4 factorial, 3 factorial. So whatever that number is the number of paths. And that's exactly what we have to apply here. So if you already know this concept, then it's easier, but make sure you kind of understand the logic here. Now it's just a matter of applying it to this condition. So first, because we have to go through 4, 6, it's really just about first finding what are my possible paths to get to 4, 6 from 1, 1. And you'll notice I'm going 3 steps east, and then I'm going 5 steps north. So we're taking a total number of 8 steps. 5 are north, 3 are east. And you can check, no matter how you go, that's the combination you'll need to get to that point. That means the number of paths just to go from 1, 1 to 4, 6 would be 8 factorial, 5 factorial over 3 factorial. And we can simplify that and compute this. 3, 2, 1, that's 6. So that's 56. Now from this point, again, we have several options. It could be something like that. But you will notice that I'm going 4 steps east, and then I am going 4 steps north. So this question is about rearranging 8 letters, where 4 are N and 4 are E. So that number would be this, 8 factorial over 4 factorial times 4 factorial, 5, 6, 7, 8. And then at this point, it's just about simplifying this. 4, 2, 10, so that's 70. And the total number of steps to go from that to this point would be their product. Why? Because you can get to 1, 1 to 4, 6 in 56 different ways. And each of those ways will then be paired with the following 70 different ways you could go from 4, 6 to 8, 10. And that's why it's a product. That's the basic counting principle. And if we multiply this, we get 3,920, which is the answer. But the most important part of this question is to see the link between how to count the number of paths with just arranging these letters. So there are two different types of problems, but the concept is the same. So make sure you understand, and I hope I've explained it clearly. But if not, maybe read up on this concept. So to summarize, the answer is 3920.